is actually backwards of what we want. So when we write this formula, this is going to give us B of T. So it's going to give us the number of bacteria at time T, which isn't what we want, right? We want to know the time it takes to get 1,500 bacteria. So we're going to find the inverse of this. We're going to switch our ordered pairs, in other words. So what's this going to look like if we switch it? I'm going to let this be B. So this is the number of bacteria at time T. So I'm going to switch them. And then what? I'm finding the inverse. So what's going to be my next step? So T over 320 equals E to 0.042B. And then to solve for B, which is an exponent, I will have to log BC. So ln T over 320 equals 0.042B. And so I'll just divide. And I'm going to get ln T over 320 divided by 0.042. Something happened with my variables. Need to use inverse notation. So this is actually the time it takes for B. This is like B inverse. So this is the time it takes for B bacteria, because this is a number of bacteria here. I shouldn't have switched those variables since I don't have another notation. See, before we switch them, because we don't use Y in our final answer, we use F inverse in our final answer. So this is actually B inverse, which is the time that it takes to get B bacteria. Okay, so let's see what we get when we plug in 1,500. So ln 1,500 divided by 320 divided by 0.042. Looks like it's 36.783. What's my unit? Days. So it's going to take me 36 days, 37 days, to get 1,500 bacteria. Now, to double check that, go ahead and go back to your original equation. This is just a check. And plug in this answer that you just got and see if it gives you 1,500. It should give you 1,500 if you plug that in. Sure enough, it does. If we needed an equation, this would be our equation. If we didn't need an equation, all you would have to do is plug 1,500 in right here and solve, which is essentially what that equation does.
So you accidentally flipped the variables?
No, I flipped them, but then, so we do flip the variables, but remember when we flip them in general, so we start with g of x equals, then we change that to y, then we switch them, right? And we get y by itself, but that isn't really y, that's really g inverse. So when I flipped them, it looked like it was still b and t, but it really wasn't, it was b inverse. So because they asked for it in that notation, I changed it to that. So the y in the original is obviously not the same as the y that you get in that. That's why you use your representation. All right, did you get 1,500? Yep, that's right. All right, there's a couple really cool problems in here I want to look at. Let's look quick, we can go back and pick up some of the others, but I want to look at H. Problem H. Because this has shown up on different things. So, what do you think about A? F is drawn. What is F inverse of -3? 3. Remember, you guys, if F inverse of something is -3, let me just call it A. If F inverse of something is -3, then F of, no, the F inverse of -3 is something. That's what I'm trying to find out. Then F of something is -3. And F of 3 is -3. What F inverse is clearly not a function. Oh wait. Does this thing pass the horizontal line test?
Yeah.
So F inverse is a function. What are C and D?
D equals X and C equals Y.
What?
D equals X and C equals Y. Like the Y axis of.
Yeah, so what would be the values of C and D? -4, 2, 3. Or 2, excuse me, -4 to 2. Because those are the Y values of the original, so they become the X values of the inverse. Passes the horizontal line test, so the whole shebang. All right, let's look at I. All right, so we're going to build some compositions, and we're going to try to figure out if any of them are linear. So what will this look like? G of H of X, what will that look like? 7 ln x minus 9. Is that linear? If I graph that, will that be a straight line? No, that's a logarithm. That's going to have a logarithm shape, so it's not that one. All right, what about H of f of x? What does that look like? ln, what's that? ln 4 to the x. Believe it or not, that's it. That's linear. What happens to that exponent? You move it out. What's ln 4? Isn't that just a number? So this is exactly the same as having an equation like y equals 2x. It isn't 2, I don't know what ln 4 is, but that is your linear equation. Everybody see that? J. Some of you get all freaked out when you see all these letters in there. What does this look like if k is bigger than 1? Isn't that just our normal logarithm? Okay, and what do we know? We know A and B are over here. And we know C, D, E, and F are over here. And we're talking about the average rate of change on this interval, and this interval. All right, let's look at A. The average rate of change on AB is negative. No, average rate of change is slope, right? That's not a negative slope, so okay, it's not A. B, the average rate of change on AB is greater than the average rate of change on CD, which is greater than the average rate of change on EF. Yeah, that's what logarithmic growth is all about. Remember, we talked about that with the tree growing and the kid learning words. What happens as your logarithmic curve progresses, it flattens out, and that means its rate of change is still positive, but getting smaller. Oh, wait, concave down? Yeah. All right, and finally K. I didn't do this one yet, so I don't know when we look at it and see what's happening. Okay, so we have all these tables of values, all right? And we want to know G is the inverse of F. So we're going to flip-flop the ordered pairs. So the ordered pairs, if we do that, are going to have 14, 17, 20 here, and then 6, 12, 24 here. All right, take a look at that. G is logarithmic because the inputs are additive and the outputs are multiplicative. True or false? I mean, that part's true. These are additive and those are multiplicative, but is that what makes it logarithmic? Nope. G is exponential because the inputs are multiplicative and the outputs are additive. No. I think it's D. It's exponential because the inputs are additive and the outputs are multiplicative.
Wait, I thought it shows that the 6, 12, and 24 are the inputs. Oh.
G is the inverse of F. Okay. Now, what? So this is exponential. What would it look like if it were logarithmic? F is logarithmic, right? F is logarithmic because F is exponential on the inputs, additive on the outputs. All right, I think we've done all except, well, I have now done them all except for, I think G is the only one. So let's look at G. And then I'll take any other questions you have, and I will have done all of the reviews then on G. Okay, what do we do here? We're solving this equation. And by the way, you might just want to make a little mental note. Whatever x turns out to be, it has to be bigger than negative 1/3. Agreed? You've got to keep an eye on that. Okay. All right. So what are you going to do here? I think we're safe. What are we going to do? Loop. So 7 to the 3rd is 3x plus 1. 343. I think we're good. 342. 342 over 3, that's something. What is that? 114? Is that all right? And then B is the one I was going to work on this weekend, this idea. And of course I didn't. So I'm going to do it the way I know is valid. I think it's a good because it keeps working for you guys, so I think it's okay. All right, so what's the issue here?
Different log bases.
The bases don't match, all right? The bases don't match. So you need to be able to make a match. If you're going to be dropping things, like dropping logarithms, they got to match. So what I'm going to do is I'm going to rewrite this guy right here as the log base 2 of 5x squared over the log base 2 of 8. Because that's what the change of base formula says. That you can take any logarithm and give it a new base. In this case, I wanted to match that one. So it's the log of this over the log of that. And the beauty is, of course, what's the log base 2 of 8? 3. So now the log base 2 of 5x squared equals 3 log base 2, 4x. This is 3. So just multiplying the 3 over to the other side. You don't drop them yet. You gotta take care of this, right? What am I gonna do with that? Where's he go? And now I can drop them. So 5x squared equals 4x quantity cubed. So the thing I gotta work on is the fact that 8 is 2 cubed. You made that an 8 and put a 3 up there, and that's exactly what's gonna come out of it. I just have to figure out why that is. Anyhow, what do I do now? Regardless of how you got here, we're all gonna get here.
Drop.
Yeah, I already dropped them, so now I'm up here.
I grow to it,
What?
or we'll get it to one side.
So 5x squared equals 64x cubed. What do you do with that?
I grow to that.
I'll draw an x squared. So it looks like x is 0 or x is 5/64. Can x be 0?
No.
No, because in the original problem, x has to be bigger than 0. Can you take the log of 0? No, not ever. So we gotta cross that out. And there's your answer. All right, I think I've done them all. Not with you, but overall, between everybody, I've gotten them all done. So, anything else you want to look at or have a question about? So you really want to get good grades. It's a big one.
You eat.
E on this paper. E. All right, let's see what we got. I'm writing the equation of a logarithm. And what do I know? 5, 4. All right, so what am I gonna do? I got a couple points. What am I gonna do? Build the equations, absolutely. So 4 equals a log base 5 of 5 plus k. Well, that's really nice, because what's that? So 4 equals a plus k. Alright, now, other one, 11 equals a log base 5 of 25 plus k. What's that? 2. So 11 equals 2a plus k. So just by plugging in my points that they gave me, I got a couple of equations. Now those equations worked out. I can do this problem without a calculator. Obviously it worked out because I'm base 5 and I had 5 and 25. If those had been other numbers, I would do the same process, but I would just need a calculator because of the decimal. Okay, well what do I do now? Yep, we're gonna substitute or eliminate. I would, yeah, you can do that. I'm an eliminator, so I'm gonna multiply this by a negative and add. But you can certainly get the k's alone and, or something alone and substitute. And now that I know A is 7, it looks like K has to be -3. So this is a system of equations. You're gonna solve it however you want. I eliminated, because that's my favorite. Oh, I need 3A plus K, just for the problem, I don't know, some puzzle thing or something. 3A plus K would be what, 18? Let's look at problem D, number 1. See if we got our graph stuff organized. Which of those equations is graphed? Problem D1. Which of the equations is graphed? Okay, I heard some noise up here in the front. It has to be A or B. Why would someone say that? It has to be A or B. It's been shifted to the right. All right, so it's A or B. All right, do we have a thought on which one of those it is? A, because it's upside down, right? Which means the leading coefficient's negative.
There's like a negative, or almost like y equals ax plus b.
Huh? What?
On the exponential.
Oh, I mean exponential.
There's a negative bracket.
Well, we did one of those earlier. Were you paying attention?
But not,
Clearly
not
not.
the negative.
All right,
like,
tell me what we got. Give me an example. I can't hear you, Gus. Speak up. -3.
-3. 1/3 to the x.
Like that? Okay, so what does that look like? That's gonna be decay. What does a negative in front of that do? Turn it upside down. Right? Yeah. So take it one piece at a time. You can do it. All right, number 2. This one's interesting. Can you figure out which point that equation would pass through? Here is your regular logarithm. What is happening in this new equation? How are we shifting it? H to the right and K up. So if you took this point right here and moved it H to the right and K up, what would be its coordinates?
Like 3, 2.
Well, we're going, no, it's H. It's H and K
H plus
variables. So if we go H to the right, wouldn't that be 1 plus H?
Oh.
And if we go K up, wouldn't that just be K? Last period, some of the kids wanted to make it HK. What would that be? HK, what would that be, Alex?
That would be, if you moved it left 1 and then did that, or like, that would be moving.
That'd be sitting on the asymptote, wouldn't it? Because if you go X minus H, isn't your asymptote at H? Yeah, so HK would be on the asymptote, so it's that, 1 plus H. How about number 3? Which of these has a vertical asymptote at -3? And you can have more than one answer. What do you think? Well, 1 is out. 1 does not have an asymptote at -3. So it's either A or C. So the question becomes, What do you think?
See,
It's gotta be C, because there definitely is a vertical asymptote at -3 on that one. And it's turned upside down. Right, we kind of already did number 4. There. All right, well, you got 3 minutes left. Look at problem A. Those are real fast problems. See how many of those you can get. Check your answers with your partner. Those are the ones we cannot
Very good.
miss. Those are the easy ones.